Welcome to our channel. Today, we're diving into the mysterious world of dark matter. We know more about what dark matter than what it. But even though it's elusive, dark matter shapes the universe as we know it. From its subtle gravitational influence on galaxies to the cutting-edge experiments trying to unlock its secrets, prepare to journey into the invisible side of our cosmos. So, how much of the universe is actually dark matter? Hold on to your hats, folks, because the answer is a whopping 27%. That's right, over a quarter of everything out there is this mysterious, invisible substance. To put that into perspective, imagine you had a giant cosmic pizza. You take a bite, expecting delicious toppings, but instead you get, well, nothing. That's because most of the pizza is actually dark matter, the invisible hand shaping the cosmos. We can calculate this by observing the gravitational effects of dark matter on things we see, like galaxies. They behave as if there's way more mass than we can account for just by looking at the stars and gas. This invisible glue holds galaxies together, preventing them from flying apart like a runaway merry-go-round. It's a humbling thought. We're a very small part of a much larger unseen universe. We live in a universe dominated by things we can't even see. Here's the thing about dark matter, it's like the ultimate cosmic ninja. It doesn't emit light, absorb light, or reflect light. It's completely invisible to our telescopes, which rely on detecting electromagnetic radiation. So how do we even know it's there? We detect its presence through its gravitational influence. It's like feeling the presence of a ghost. You can't see it, but you know something's there. Light is how we perceive the universe, but dark matter reminds us that there are entire realms beyond our immediate perception. There's a whole lot more out there than meets the eye, or the telescope. And that's what makes studying dark matter so tantalizing. Our story begins in 1933 with a Swiss astronomer named Fritz Zwicky. He was studying the Coma Cluster, a massive gathering of galaxies about 320 million light-years away. Zwicky, known for his direct personality, noticed something strange about the galaxy's movements. They were zipping around the cluster much faster than they should have been based on the visible matter alone. It was as if something invisible was giving them an extra gravitational kick, like an invisible hand stirring a cosmic pot. Zwicky proposed the existence of dunkle Materie, which translates to dark matter in German. His idea was initially met with skepticism. Little did Zwicky know, he had stumbled upon one of the biggest mysteries in astrophysics, one that continues to baffle and inspire scientists to this day. Chapter 4. Galactic Spin. Doctors, how dark matter controls galaxy rotation. Let's talk about galactic rotation. You might think stars orbit the center of a galaxy like planets orbit a star, with the ones farther out moving slower. Makes sense, right? Well, here's where things get weird. Astronomers have observed that stars on the outer edges of galaxies are moving much faster than they should be based on the visible matter alone. It's like watching a spinning figure skater extend their arms and somehow spin even faster. Enter dark matter, the invisible conductor of this cosmic orchestra. Its gravitational influence provides the extra mass needed to explain these unexpectedly high rotation speeds. Imagine a galaxy as a giant merry-go-round. The visible matter is like the horses and decorations we see, while dark matter is like a massive invisible platform beneath them. Without it, galaxies would likely fly apart due to their own rotation. Chapter 5. Beyond atoms and quarks. Why dark matter isn't like normal matter. Now, you might be wondering, if we can't see dark matter, could it be made of the same stuff as us? The answer, my friends, is a resounding no. The matter we interact with every day, from the air we breathe to the stars in the sky, is called baryonic matter. It's made up of atoms which are composed of protons, neutrons, and electrons. Dark matter, however, is not made of these familiar particles. It doesn't interact with light or other forms of electromagnetic radiation, which is how we detect baryonic matter. Dark matter simply doesn't play by the same rules as the matter we know and love. This fundamental difference is what makes dark matter so baffling. It suggests the existence of particles beyond the standard model of particle physics, our current best understanding of the fundamental building blocks of the universe. Chapter 6. Enter the WIMP, the leading candidate for dark matter. One of the most popular theories about dark matter is that it's made of something called WIMPs, which stands for weakly interacting massive particles. Catchy, right? Now I know what you're thinking, scientists love coming up with complicated names for things, but there's actually a good reason for this one. WIMPs would be massive particles, much heavier than protons and neutrons, which would explain why they have such a strong gravitational pull. But here's the catch, they would only interact with normal matter through the weak force, which is responsible for radioactive decay. And the weak force, as its name suggests, is incredibly weak. Think of it like this. Imagine a WIMP is like a ghost walking through a wall. It passes right through without even noticing the wall is there. That's why WIMPs are so difficult to detect. Despite the challenges, scientists are actively searching for WIMPs using a variety of experiments, which we'll talk about later. Chapter 7, Cosmic Architects, How Dark Matter Builds Galaxies. Now let's talk about how dark matter played a crucial role in shaping the universe as we know it. In the early universe, things were much more evenly spread out. There were no stars, no planets, just a hot, dense soup of particles. But over time, gravity began to pull matter together. And because dark matter makes up the vast majority of matter in the universe, it had a significant gravitational advantage. Imagine a cosmic web, with dark matter forming the threads and galaxies forming at the intersections. Dark matter acted as the scaffolding upon which galaxies were built. Without dark matter, galaxies would have likely formed much later and would be far less massive than they are today. Chapter 8, Einstein's Cosmic Telescope, Using Gravity to See Dark Matter. So, how do we study something we can't see? Well, one way is to use a phenomenon called gravitational lensing, which is like nature's own cosmic magnifying glass. Here's how it works. Imagine a distant galaxy emitting light that travels towards Earth. Now imagine a massive object like a cluster of galaxies dominated by dark matter, sitting between us and that distant galaxy. According to Einstein's theory of general relativity, massive objects warp the fabric of space-time. This warping can bend the path of light, acting like a lens. By studying these distorted images, astronomers can map the distribution of mass in the lensing object, even if that mass is invisible dark matter. Gravitational lensing is a powerful tool for studying the distribution of dark matter in the universe, providing further evidence for its existence and influence. Chapter 9. The hunt is on underground experiments and the search for dark matter. While astronomers study dark matter's effects on a cosmic scale, other scientists are taking a more direct approach, trying to detect dark matter particles here on Earth. Remember those WIMPs we talked about? Well, these elusive particles are thought to be passing through us all the time, rarely interacting with normal matter. To increase their chances of catching a WIMP interaction, scientists have built ultra-sensitive detectors deep underground, shielded from cosmic rays and other background noise. Imagine a giant vat of liquid xenon kept incredibly pure and chilled to extremely low temperatures. If a WIMP were to collide with a xenon atom, it would create a tiny flash of light, which the detectors could pick up. These experiments are like trying to hear a whisper in the middle of a hurricane. So far, no definitive WIMP signal has been detected, but the search continues. Chapter 10. The universe's biggest mystery, dark matter's secrets remain. So there you have it, 10 mind-blowing facts about dark matter. Despite all we've learned, the true nature of dark matter remains one of the biggest mysteries in astrophysics. The search for dark matter is a testament to the power of human curiosity and our insatiable desire to understand the universe and our place within it. And who knows what other mysteries await us out there in the vast expanse of space. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating content about the universe. We've only scratched the surface of dark matter's secrets. There's so much more to learn about this elusive substance that shapes our universe. Stay curious, keep exploring, and never stop asking questions about the cosmos. After all, the universe is full of wonders waiting to be discovered.